Hey, my name is Naresh. I'm going to start a series on the open table formats like the Hoodie, Iceberg, and the Delta Lake. So before we start into the open table formats, so let's revisit our legacy Hive table formats and what are the advantages of it and what are the disadvantages of it so that we can understand the necessity for these new table formats introduction into the data space. So if you look at the Hive table format, uh, the data gets stored on the file system in the form of the directories and the files, and you create a table definition saying that this is the location for my table and this is the partition structure for my table, and then data gets stored in the meta store called the Hive meta store. That meta store is used by the engines like the Hive or Spark or Flink. So all these engines, if you wanted to understand the what is the data in this table directory or the file, they will talk to the meta store, and the meta store will tell us them, okay, here is the path of the table base path, and here is the table partition structure. So that these engines will go and read those file systems. And this is the de facto standard for quite some time, but what is the advantages with this standard is, assume that you wanted to read a partitions in the specific partition called A, then you don't need to go and read all the directory. You don't need to scan all the directories and read all the directories under that path. If you are reading for a partition A, then your table can go to the specific directory with the partition A and can read only those tables. So that is means the efficient query patterns. We don't need to read entire directory structure to read the tables data. And the other advantage with this Hive table format is that you can store the data files in whichever the file format you required. The file formats are like CSV, JSON, Avro, Parquet, and Hive decouple the file format versions from these storage. So not from the storage. Hive is Hive table format allow us to choose whatever the format we feel good for our workloads, either row oriented file formats or the column oriented file formats or the semi structured file formats. So the and other advantage with this Hive table format is you can make the changes to the individual uh, partitions or in an atomic way. Assume that you are trying to make a changes to the partition B. What your engine can do is engine can rewrite all the partition directory, and then it's once it generated the partition directory with the changes, then it can simply update the partition directory path in the Hive metastore with the new partition directory path, and then delete the old partition directory. So that means there is no data corruptions. So these are some of the advantages with the Hive table format, but there are certain disadvantages is also there. So the certain disadvantages is because the way it represents the tables data. So in the Hive, it uses the directory structure to, and subdirectories is to represent the table and the partitions. So with this, then it would be very difficult to update a file level changes. Assume that you have some error in a certain file in the partitions. Then you there is no way for you to go and update only that particular partition. Either you have to fully update the partition that includes all the files. That means you have to rewrite, or like uh, mm, there is no way to go and update only in that particular a file that is having the row. That is a file level changes is difficult. So other disadvantage with is that multi-partition update. Like if you wanted to execute some kind of the transaction where you wanted to update the multiple partitions at a time, it would be difficult to do the multi-partition update. uh, and also this the same applies for the concurrent updates. Like you cannot two process cannot update the one particular partition at a time. That's a concurrent updates are not possible. And and as I mentioned, that the Hive table format is going to store the data in the form of the directories and the subdirectories. Then these query engines require it to list these files and directory before reading those files. So this is a listing is a time consuming process for these query engines. To give an example, let's say it's trying to read a partition A, then it needs to go to the partition A directly and list all the files and then read all those files. It would be very difficult. So, and to give an example, let's say you have a under the partition A, assume that you have a five files. In one of those files, you have a record that you are interested. Then your system has to the query engine has to list all the directories and then read all those files in those directory to find those record that you are interested. This is a time consuming process for this query engines. And also for the efficient query processing, these Hive table format will maintain the table stats in the meta store. But the table stat is in a separate process. Their separate process is not part of the ingestion process. So there could be a possibility that there may be a stale table stats available, and that will impact your query performance. And the most important disadvantage with the Hive table format is updates. So assume that you have to update the table. Assume you update a new column data type or add a new column to the table. It would be very difficult. You have to either entirely rewrite the table definitions, or if you wanted to remove the partitions or add a new partition, in both the cases you have to rewrite your entire tables. Assume that you have a data that is of few GBs of that, 100 or thousands of GBs of data. It would be very time consuming process to rewrite those tables. So these are the some of the disadvantages with the Hive table format. So to add why so to understand why all these are disadvantages is because the in the Hive represent the table as a set of directories and subdirectory instead of a files. So because of this one, the new table format were introduced, and they represent the table as a set of file instead of the set of directories. So that will allow, since you are representing the table as a set of files, there is a possibility for you to do go and update and read only certain files only those having our data that we are interested in. So this is one of the that is one of the change introduced in these new table formats, opened a lot of use case, a lot of other benefits like the asset asset benefits. Like you can do the atomicity, consistency, isolation, and durability. Along with that, it also gave the time travel, so it will allow you to find the status of your table few days back, few hours back. And other thing is we can easily update the table definitions, like you can simply add the column, new columns, delete the columns, or may add a new partition column, or remove a new partition columns. The schema evolution is the great thing about one of the advantages of these open table formats. And also the small file problems, in the Hive, there is, if you have a small file problem, then there is no way for you to combine these files and generate a big data files, right? So but that's called the compaction. So that is also resolved in these open table formats, because they maintain a lot of metadata related to the file, and so that the query engines need not go to the all the files to read find a specific rows or data. And also the engines, this file format allows to these engines to do combine these small files and generate one bigger file. As I mentioned, so this open table formats managing a lot of metadata for these files, table stats, min max rows, and what is the status of the table, what are the active files, active files as part of the tables which are deprecated. All those information get stored, so that will help us the query engines to efficiently query these tables data. So if we have to, let's take a look at the how these open table formats store these metadata, and how they lay out the file system onto the storage. So this is an example for the iceberg, where in the iceberg, it is also have the catalog, where it will point to the it will have a main pointer. The main pointer will point to the table, to the meta file. So it will basically like assume that you have a table one, and table one have a meta file related to this is the location of the meta file. That's only the information stored in this catalog. And this meta file in turn will contain other meta files, metadata files called the manifest files. Those will contain other manifest files, and these manifest file actually point to the data file. So if you see this hierarchy of these like the segregation or hierarchy of these metadata files, will allow any query engines to efficiently query and easily update the files, update the files or data or the partition information. So in the next video, I'm going to show the either Hudi iceberg. We'll try to generate the Hudi iceberg table, and review the metadata file generated as part of those table definition. Thank you for watching this video. Hope you like this video. I'll see you in the next video. Bye bye.